Hey, let's do a quick little video, kind of talk about a couple of the questions in some of our homework here. Number 3 from homework number 1. I love this question. This is a question that takes in lots of skills, and it relates things to trig, and it relates things to implicit differentiation, product rules. So it just ties lots and lots of concepts together. So I've got some colors thrown in here just kind of help us out. The key thing is when you're given a cosine ratio, its derivative is negative sine ratio. And then whatever you have for your angle, whatever you have for theta, doesn't change in the first layer. And then in the second layer, kind of like we did back in some problem solving, when you have x plus y, you take the derivative of x plus y. And of course, the derivative of x is 1, and the derivative of y is dy dx. And then on the other side here, you've got a product rule. Your first function is y, and your second function is sine of x. So what's f prime? F prime is 1 dy dx, and g is sine of x, and then your f is y, and then your g prime is cos of x. So again, we've got the layers. We've got cosine layer that goes into negative sine of theta plus the derivative of the angle itself. And then when you want to simplify and solve for dy dx, now we're going back to some nice algebra from Math 10 or Math 20, where you use your distributive property, and you got some brackets in here. So you multiply whatever's on the outside into the brackets. So negative sine theta times 1 is negative sine of the theta, and negative sine theta times dy dx is, and what I did here, I just changed my notation. I went from dy dx to y prime, and I did it in both of them. So again, way back in the early chapters, we talked about different notations. So that's why this dy dx became y prime. But it's negative sine of your theta times by y prime or times by dy dx. And we want to then be able to figure out where do I want to put my dy dx's, where do I want my y primes to minimize the number of negative signs. If I move this negative to the other side, it becomes a positive. If I take this y cos x to the other side, it becomes a negative. And then when you've got your y primes together, you can factor them out. So y prime factoring out of sine x is y prime times sine x, and the y prime factoring out of sine x plus y leaves the sine x plus y. So that's kind of my hints, I guess, in terms of doing question number 3.